This video continues my review of the arguments of Panda's read CSV function. In this one, I will specifically be discussing the various options available to you for reading in and manipulating date values from a CSV. On the screen, you can see a very simple CSV that I will be demonstrating this with. It contains several columns of dates in various formats. Column B is a date in the standard format that Excel stores dates. Columns C, D, and E contain the exact same dates as column B, but are separated by month, day, and year in their respective columns. Column F contains the same date, but written out by day, month, and year. The final column is a column of the same date, but in an unusual format. Sometimes dates are stored in an unusual way, and this column will help demonstrate how to handle those odd cases. Moving over to Jupyter Notebook, you can see I am importing read CSV from the Pandas library. I am using Pandas version 2.0.3 for this demonstration. First, let's just bring in the CSV to show the data. We can see all of our columns and dates here without any formatting yet. They are currently output in the exact same way as you see them contained in the CSV. We can also see that no date-time conversion is happening by using the dtypes attribute. All the columns are either integers or objects. The arguments we will be working with are the following, which you can see at the bottom left-hand corner of my screen. Parse dates, keep date call, dayfirst, date format, and cache dates. Let's start with parse dates. Parse dates takes as an argument the columns you wish to turn into a date-time series. It accepts a list of either the column location or the column name. First, let's see what happens when you parse just the date column. This output shows a different format from the initial read. The date is year-month-day instead of the format that looks similar to the column titled dayfirst-date. This is because the date column is now a date-time type. You can see that by looking at the dtype attributes of our data frame. We can perform the exact same operation using the name of the column instead. Using the column name is particularly useful when you are working with large datasets. But now what if we have the date over several columns, as we have right here with the month, day, and year columns? You can actually pass parse dates a list of columns that make up a date when combined together, and it will turn those three columns into a single one of a date-time type. Here you can see our initial three columns have disappeared, and in their place is the month_day_year column with the correct dates. You are not restricted to only one date column at a time. You can pass multiple columns that you want to transform. This new line of code adds back in the date column while still transforming the month, day, and year columns. You can accomplish this with some list nesting. The output shows both columns now in date-time format, which can be verified with dtypes. The next argument up is keep date call. This argument determines if the original columns that we are transforming into a date-time column are retained in the data frame. It is Boolean, so it accepts true or false, and its default is false. That is why the three columns of month, day, and year above were replaced with a single column. Let's run this with its default behavior first. The month, day, and year columns have been removed as they were before. Now, if we want to retain those columns and keep the history of where the date-time column originated from, we can set this argument to true, and the initial columns are not dropped. Here we see that they are retained. The next argument is dayfirst. This is another Boolean argument, and it is asking if the incoming date data has the day instead of the month at the start. Our dayfirst date column will be useful here. Let's first see what happens when dayfirst is false. The column doesn't change. It is still an object. So let's change it to true. So right here, I will just type out true. Changing it to true shows that the column has changed and the type is now correctly set. If you try using the dayfirst argument on a column that doesn't have the dayfirst, it will prevent the conversion from object to datetime, as you can see with the date column. So always be careful to only use it whenever it's necessary. The next argument is date format. This one allows you to specify to pandas how the date is formatted in the CSV. Our column named strange format will help us understand this. The column contains the year, month, and day, with Y, M, and D respectively. Now, admittedly, this is a horrible way to store this data, and I hope you would never see anything like this out in the real world. But it is useful as a demonstration of the control that you have when using read CSV and trying to clean up a mess like this. I am explicitly stating in my date format argument the way the date is contained in a string in each cell. This tells read CSV how to read each cell and parse the date appropriately. Executed, we can see the converted date in the strange format column. The final argument we'll be reviewing is cache dates, which takes a Boolean value of true or false. For this, I will be using a different CSV, this one called test lots of data. It contains over 600,000 rows of dates and random numbers. Cached dates works best on large files because it stores in the cache a list of the unique dates that have been parsed. This can significantly speed up read time because pandas pulls the dates from the cache anytime it finds one that it has already performed the conversion on. Otherwise, it would be converting every single date to datetime, regardless of how many times that specific date appears in the CSV. In my date column, I have listed these 10 dates over and over again, thousands and thousands of times. So let's close the CSV and see what happens when we state false, which is not the default behavior for pandas. Running this, you can see that it takes several seconds to complete, and you notice that it was lingering on this cell execution for longer than you would expect. This is because it is performing that transformation every single time it comes across a date. Now, let's switch this to true and see how long it takes. We can see it is just a matter of milliseconds. Once again, let's go back to false and see what happens. And this is a clear example showing that not caching the dates is significantly slower than caching. And with that, this concludes the deep dive of each of these arguments for pandas read CSV. To sum it up, parse dates accepts the columns you wish to turn into a date type series. Keep date call retains the columns that were transformed into a date time series. Dayfirst specifies that the incoming dates have the day listed first. Date format allows you to tell pandas what the date is formatted like in the CSV. And finally, cache dates, which allows you to store the dates in cache so that it doesn't have to perform all the logic to convert dates every time it comes to a date it has already encountered in the past. And that's it. And as always, thank you for stopping by and watching, checking out this video on Read CSV. Please leave a comment below with any questions you have or comments letting me know if you like this video. Don't forget to give it a thumbs up so others can see it. And please hit subscribe so that you know when the next video drops.